familiar. So if you don't know by now, then you should probably get familiar.
Hi guys, welcome to Vedant EduNation. Today I have one more question for you from GATE 2017 Electronics and Communication paper on uniform plane waves. So here is the question. The expression for an electric, so there are four options. Does not represent a plane wave, represents a circularly polarized plane wave propagating normal to the z-axis. Option C is represents an electrically polarized plane wave along the xy plane, and option D represents a linearly polarized plane wave. So once we want to find the right option here, and when we look at the options, the first thing is to make sure that this is indeed a plane wave, and then we can cross out the first option. So in order to find whether this is a plane wave or no, we have to first write down the electron propagation. So the k vector here is, the k vector gives the direction of propagation. Here the k vector is equal to kx minus ky, and the electric field vector E is equal to E naught x plus y plus j to z. So the k vector is given by this, where x and y are vectors, and the electric field vector is given like this from the given question. First we have to find out whether the given electric field expression is a plane wave or no. In a plane wave, the electric field vector and the propagation vector are orthogonal to each other. Also, the magnetic field and the electric field are orthogonal to each other, and they lie in the same plane, and both the electric and magnetic field are orthogonal to the direction of propagation, which is the k vector direction. So in that case, the dot product of k and the E has to be 0 in order for this to be orthogonal. So in that case, if k dot E is 0, then this becomes a uniform plane wave. So let's just do this calculations. K dot E, so k dot E is equal to kx dot x minus ky dot y plus 0 dot j to z. So this becomes k minus k, and it is indeed 0. Since k dot E vector is 0, the two vectors are orthogonal to each other, hence this is a plane wave. So the first option is out. The next option says that this wave represents a circularly polarized plane wave propagating normal to the z-axis. To do this, we will to find the right answer, we will first visualize this wave, in which plane it is propagating, and the k vector and the electric field vector. So let's just draw the visualization of this vectors. So here you have x and y vectors, and we have the z vector coming out of this plane. So the z vector is coming out of this plane, z axis is coming out of this plane, the z axis is coming out of this plane. So first thing, we will draw the k vector. The k vector is given here, which is x minus y. So x here is positive here, and minus y is positive here. So the k vector is like this. So this is the k vector, and next thing is to draw the electric field vector. So let's just draw the x and y component of this electric field vector, which is x plus y. So it's like this. So this is x plus y. The z component of this vector is out of this plane, which is consistent with the plane wave propagation, since that k vector is orthogonal to the orthogonal to the electric field at all the times. So now Let us see what the options are. So, the first option says represents a circularly polarized wave, which could be possible, propagating normal to the z axis. So, the z axis is here and it is propagating normal to the z axis, which is true, but there is another option, represents an elliptically polarized plane wave propagating along the xy plane, which is also true because the k vector is in the xy plane. And the third option is that it says a linearly polarized plane wave. So, we have to find the polarization of this wave to answer this question. So, the polarization of this wave has to be found out. In order to do that, what I will do is to visualize the vectors. The first vector of the electric field is x plus y, which is in this which lies in the xy plane, and we have the z vector which is coming out with the phase of j. So, that with a phase of pi by 2, that means we can write the electric field vector E equal to E naught x plus y plus e raised to j pi by 2 to z. So, in this case it has a phase difference of pi by 2, the z vector which is along this direction, comments below. That makes this plane wave either circular or elliptically polarized. In order to find, so it is the option D is not now gone, so it is not option D. So, the plane wave has to be either circular or elliptically polarized. So, the final thing is to find whether this is circularly or elliptically polarized. The magnitude of the z vector which is coming out of this plane of the paper is 2. So, the magnitude is 2, and the magnitude of this vector which is in the xy plane is root 2, because it is just square root of 1 square plus 1 square. So, it is root 2. So, the magnitude are different. In that it would be a circularly polarized wave if the magnitude are same, but since the magnitude are different, it has to be elliptically polarized. So, the option B is also gone. So, the right option is C. So, this problem is quite interesting in that you have to find out, you have to visualize all the vectors and also find out the polarization by your imagination. Thanks for watching. Please subscribe to our channel and check out the videos and other books I recommend.